So one of the ways to do it, ratio tables, they only work when you share a factor. It could be any factor. The factor these share is 5. To get from 100 to 5, we divide by 20. To get from 5 to 95, we multiply by 19. So what we would do is the same to the top. Now, the easy way we do it, like I said, is just keeping it as a fraction and not simplifying. This means 6. This means divide. That means 20. Remember what our division sign looks like and how those are placeholders? Right. Exactly, 6 divided by 20. Then we need to multiply it by 19. But when we multiply, we only multiply the top. So 6 times 19 is 114. Then we divide that by 20. What happens there? One thing we can do is we simplify it. I divide them both by 2, which is the greatest factor they have in common. I get 57 over 10. And then I can do my decimal trick, which I'm going to show you in cross multiplication. The decimal trick. The decimal trick is anything over 1 is just itself. Anything over 1 is just itself. So if I want to make this over 1, the decimal's right there, right? All I need to do to make it over 1 is move our decimal there. Same thing on the top. So we get our answer to be 5.7. So this was our initial, this was our limbo, and that's our end. And we would get it to be 5.7, which makes sense. That makes sense. So here's the thing though, like I said earlier, ratio tables do not work unless they share factors. So for example, if we had our problem and we said that it was 97, do 97 and 100 share any factors? They share 1, which technically, yes, we could do it to 1. We would divide 6 by 100 and then multiply that by 97 divided by 100. But guess what? That's cross multiplication, and we'll get to that. So ratio tables only work if you have a factor in common, and they work the best when you have decent factors in common. Now, that's how ratio tables work. The next one we're going to look at is cross multiply. So once again, we're trying to find 6% of 95. The way we set this up is using equivalent fractions. What does equivalent mean, Hannah? Equal. So what's our initial fraction? Madison. 6 over 100. Exactly. Percentage always over 100. And then what's going to be the bottom of our equivalent fraction, Matthew? 95. Exactly. So our top, because we don't know what our answer is yet, I like to use a variable. That just is a placeholder, just like our division sign. It's just a placeholder. We don't know what it is yet. In this case, we do cross multiplication. I'm going to show you the one way, and then I'm going to show you the other halfway, and it's the same sort of thing. So what we need to do is we multiply. This is a little hard first. We have 6. We have 95 times 6. And then also, we have 100 times x. This is hard to think about, but let's think about this. What do I have 100 times scooter? What do I have? 100 times scooters. I have 100 scooters. What about 100 times students? What do I have? 100 students. So what's 100 times x? 100x. It's literally that simple. 100x. So let's solve for 95 times 6. 6 times 5 is 30. 6 times 9 is 54, so we get 57. So what we get is 570 is equal to 100x. Now we need to do that thing I said yesterday. Do you remember what the exact phrase I said yesterday was? Let's see if anyone can say the exact phrase. Miles?
You have to make a unit rate?
That's really smart. It's kind of like unit rates. So remember, we're going to do something, and this is an important term that you will need to know in future math, and you'll need this in all future math. It's called isolate the variable. If we put something in isolation, if we isolate something, what does that mean? If we put something in isolation, Rafi? It's a good idea. Keep it in place. That is pretty accurate. Trey? We separate it. We keep it completely alone. We want to isolate the variable. What is a variable? Who can tell me what a variable is, Hannah?
It's like a placeholder.
It's a placeholder. So which in this thing right here is our variable? Madison? The x is our variable. Technically, the 100 is what's called a coefficient. We won't need to know that yet. But in this term, we have this is our variable, this is our coefficient, and this is our constant. Those are just the names for them. We want to isolate the variable, which means we want to get rid of this 100. We get rid of 100 by dividing by 100. So we divide by 100 on each side. Here's the two ways. Remember, this is why I said there's a half way to do it. The first way to do it is to do long division, right? It's not fun, but it works because we get 0, 0, 5, 570, decimal, 7, 700, 0. 5.7, what we got earlier. Or we can just be smarty pantses and know that we move our variable. Anything over 1 is itself, just kind of like our unit rate. So how many times do I have to move the decimal here? How many times, Hannah? 2 times. We move it over 1, 2. Awesome. So that's my answer, right? 570 over 1? No. What do I have to do, Madison?
What you do to the bottom, you have to do to the top.
Exactly. What we do to the bottom, we do to the top. What we do to one side, we do to the other. What we do to one side, see how we did it on this side, we do it to the other. What we do to one side, we do to the other. What we do to the top, we do to the bottom. So again, we get 5.7. Again, we get 5.7. This is the easiest. In fact, this is what our first unit was on. This is what we did in chapter 5. We multiplied decimals. And we didn't even have some of the students here for chapter 5 who are still excelling at this multiplying decimals. Let's think. First things first. Where's the decimal point on 6%? Where's the decimal point on 6%, Miles? It's an invisible one, so where is it? At the end of the 6, exactly. If we don't see a decimal point, it's at the end. How do I make 6% into a decimal, Lucy? We move 2 spaces, perfect. So I go like that? No, I go away from the percentage sign. So I go 1, 2. To make it not a percentage, I move away from the percentage sign. So my new answer is 0.06. And then of actually can in some cases mean multiply. So of means multiply. So I'm going to use this as our term for multiply by 95. By 95. Then we know how to do this. We set it up. 95. How do I multiply 0.06 times 95? How do I do that, Lucy? We line it up to the right. That's the most important thing. Whenever we're doing multiplication, we always line it up to the right, which means it looks like this, 0.06. Always, always. Now, when we multiply with decimals, we move them over and then move them back. So we move them over 1, 2. So at the end, we're going to move it back 1, 2. Excellent. Excellent. So now we're going to do our multiplication. We already did this before. 6 times 5 is 30. 6 times 9 is 54. 54 plus 3, we get 57. Look, we moved our decimal back and we get 5.7. 5.7. Those are the 3 ways that we can do it. Those are the 3.5 ways. In your books, I want you to try to find 15% of 110. 15%. We want to make it into a decimal. So where's the decimal point? Oh my gosh, on 15%, Miles.
At the end of 15.
At the end of 15. If we don't see a decimal point, it's at the end. How many places do I move it over and what direction, Anita?
2 and to the left.
2 to the left. Move it over 1, 2. We move it away from the percent sign to make it a decimal and towards the percent sign to make it a percent. So our answer we get is 0.15. 0.15. Then we need to multiply that times 110. We multiply that times 110. So we just set it up. We got 110, and we always line it up. This is where people make mistakes, so focus. We always line it up at the far right side, 0.15. Doesn't matter, far right side. Now we need to put the decimals back for a second. It's a whole thing. We move it over 1, 2 decimal spots. We're going to move it back at the end, 1, 2 decimal spots. So if we did this problem, we would get 0, 5, 5. Our magic 0, normal 0, 1, 1, right? We add these together to get 0, 5, 6, 1, and then we have to move our decimal place back 2 places, 1, 2. So we get our answer to be 16.5. Our answer is 16.5. Homework is going to be page 153 only. That is the front side of the extra practice for lesson 7.